Assalamu alaikum. Now we will discuss about the design of single column footing. There are several steps. One by one we will discuss all the steps. Firstly, we have to take the soil bearing capacity from soil test report, column dead load and live load from model analysis result. Calculate the footing size, perform punching shear, perform beam shear, calculate the steel requirement, calculate the minimum steel, and finally the detailing. Step 1, collecting all the parameters. Soil bearing capacity QA, this is obtained from soil test report. Dead load of column, live load, F prime C, Fy, unit weight of soil, unit weight of concrete, depth of footing, effective soil bearing pressure. Actually, I think everyone knows all the basic things, so I cannot elaborate the simple things. If anyone cannot understand, please contact with me. Step 2, footing size determination. Footing area equals to dead load plus live load divided by QE. The footing area 91.5 square feet. We assume any convenience size which is practical, 9.5 feet into 9.5 feet. Step 3, punching shear check. For strength design, the upward pressure by the factored column load is factored column divided by footing area. We assume the thickness of footing 19 inch. Actually, this is not the thickness. This is actually effective depth of footing. We need to mark the critical perimeter ABCD, which is denoted as B naught. This is actually the four arms of this area ABCD surrounding the column. The shear force acting on this perimeter ABCD equals to 492 kips. The corresponding nominal shear strength for root over F prime C B naught D, shear reduction factor 0.75, and finally the allowable punching shear 533 kips, which is greater than 492 kips. That means our effective depth D 19 inch is sufficient for punching shear. Step 4, beam shear check. The shear force acting on the section EF. This is EF. The force acting on this section, on this part, equals to 140 kips. The corresponding nominal shear strength equals to 2 root over F prime C B into D. Please be careful for the unit conversion. All these parameters are in inch, so B must be in inch. Here B equals to 9.5 feet, and you need to multiply with 12, and then we get 274 kips, which is greater than developed shear 140 kips. That means 19-inch effective depth is also sufficient for beam shear check. Shear reduction factor, allowable beam shear 205. That means allowable beam shear check is greater than 140 kips developed shear. So effective depth D is sufficient. Now step 5, moment and extent calculation.